Video we're going to review about even and odd functions. So even and odd functions are actually an algebraic conditions, but they are equivalent to geometric conditions. We define this: a function f is even if and only if f of the opposite of x is the same as f of x. So it turns out, however, that this means that even functions are exactly those functions which are symmetric with respect to the y-axis. Examples include even degree power functions, hence the name even function, absolute value of x function, polynomials with all even degree terms, and other things. The cosine function is even, for example. And so, for example, f of x equals x squared is an even function because f of the opposite of x is the opposite of x squared. When you square the opposite of x, you get the same as x squared, which is the original f of x. So changing minus x got us back to where we started. So it is symmetric with respect to the y-axis. A function, on the other hand, is odd if and only if f of the opposite of x is the opposite of f of x. Turns out that odd functions are exactly those functions that are symmetric with respect to the origin. And examples will be odd degree power functions, polynomial functions with all odd terms, and, for example, the sine function, and others. So, for example, f of x equals x cubed is an odd function because f of the opposite of x would be the opposite of x cubed. Three negatives multiplied together is a negative, so that's the opposite of x cubed, which is the opposite of f of x. So f of the opposite of x is the opposite of f of x. So it has symmetric. It has the algebraic condition for being odd. Notice that this changing x here will reflect over the x-axis, and this changing the outside here will reflect over the y-axis. If you do the two, you're back at the original f of x. And so those two flips makes a rotation of 180 degrees about the origin. If that does put you back where you started, that means you have origin symmetry. So notice that if a function is even, or if it's odd, it has a very special property. It must have some form of symmetry. On the other hand, functions in general might not have any symmetry, much less those specific kinds, y-axis or origin symmetry. So most functions are neither even nor odd. A function cannot be both even and odd, with the exception of y equals 0, the x-axis. However, it could very easily be neither one. So most functions are neither even nor odd. If it's a polynomial function, all the terms have to be even degree. Remember, a constant term is 0 degree. It's even. If the function is a polynomial, then if it's all even terms, then it'll have even degree terms. In other words, all the powers of x are even numbers. That'll be an even function. And if the polynomial has all odd degree terms, then that's going to be an odd function. But if it's got a mixture of odd and even powers, it's neither. So this one is even. The degrees are 0, 2, and 4 here. And you can see that by saying f of minus x, put in minus x here and here, reduce that down, it reduces to the original f of x, so it's an even function and it's not an odd function. This one is all odd powers, it's an odd function. When you put in minus x here, here, and here, we get this. It's not the original, so it's not an even, but we can factor out a -1, and what's left inside the parentheses is the original, so it is an odd function. This one down here is neither one. If you put in minus x here and here, you don't get the original. If you factor out a -1, what's left inside is not the original, so it's neither even nor odd. That should say, let me fix that. These should all be the same letter. There we go. Those should all be H's in the last one.